What's up, folks? This is the Savage Scientist, and this article came across my desk today, and I said to myself, this will be a great topic for my video. So let's talk about the pillars of object-oriented programming. This is a great article because it covers a lot more than just object-oriented programming. And as you know, it's Christmas time, and those presents have to get paid for somehow. So in a future video on Vlogmas, I'm going to talk about why having a job is so important. I got some of my best jobs within 2 or 3 days, either before or 2 or 3 days after Christmas. And this is the Christmas spirit to me. Get me in the Christmas mood to think about having money, having a damn job. So being employed is one of the best things. I tell you, I do not like being broke for Christmas. So, fundamental pillars, object-oriented programming. I'm going to skip a lot of the stuff in this, and I'm going to put a link to this article in the description below. So basically, object-oriented programming falls in these four categories: abstraction, encapsulation, inheritance, and polymorphism. And basically, abstraction just means that you're gonna take a base class like a car, and then it's gonna implement car. So you might have a Ford that's implementing a car. You might have Honda that's implementing a car. I'm not gonna use Tesla here. So you might have Cadillac that's the implementation of a car. It's gonna share all the common attributes of car, and it's gonna be its own thing. So Ford inherits car. Encapsulation is something similar, but it could be a little different. So this is just wrapping the code up until it becomes its own unit. So the variables, the methods, and all that stuff is within the class. So car, you're gonna have special variables for car, special subclasses in this thing, in the class for car. So that's what it's saying here. And you're gonna have all the variables to work with car, all the methods and variables. Most of the time, the variables will be set through common functions, so you won't be able to access the name of the car. Or like let's say you have a Ford, and then you create something like a F-150. You can't change the name F-150 by accessing the data directly. You have to use one of these encapsulated methods or public setting methods to change the name. More of that is coming as I talk more about object-oriented programming in the future. And inheritance just means that it's almost this whole thing going backwards. So you're gonna have a base class, and then it's gonna derive from that base class. Polymorphism just means you're gonna have one name for one. You're gonna have a function that has a single name, and then it's gonna have a lot of different ways to put data. So some of these functions might take one parameter, or you might be able to put multiple different ways of interacting with that function with let's say, let me see what example they're using here. So let's say you have a function. I'm gonna have to write this out for you. That's gonna take in an int, and we're gonna name this function f. So you might have another one, f, that takes a string. So f has you have two different versions of f, one for string and one for int, and you could use those in your code. So when you call it f dot, and depending on what you supply in here is going to determine which version of this function we're going to use. And what I mean by that is f called with the number 75 mean we're going to use the one with integer, f dot, let's say string, let's see, so that's the word 75, that's going to call this one. So that's all this is doing. It's just a way of addressing, I'm just giving you a quick example of polymorphism. So let's move on to some more of this stuff. And as you can see, this article is filled with advertisements. So let's get past all those. So another thing that they talked about that I really like is multi-threading. That's another topic that's going to be in my advanced courses that's coming. So this is just showing you CPU memories, you know, and threading. Multi-threading is very important. You're creating threads that's gonna run it's gonna open up processes on the CPU, or it's gonna actually, the processes don't really run on the CPU. It's gonna create processes that the operating system is gonna run concurrently on the CPU. So that's all threading does. So then you run into situations where you have one thread that might be waiting for another thread. So you have deadlock situations, or what they call right here race conditions. And that just means two things trying to happen at the same time. That's why when you go to the bank and you have, let's say you have two ATMs set next to each other, you stick your card in one ATM, and then, or let's say you have two cards that have access to the same bank account. So trying to be slick and clever, you stick two cards in the ATM, and then you try to withdraw from your bank account 2 times, thinking that the account will not do it. But what's going to happen is it's just going to allow one transaction to happen, and the other one is going to wait. And once the other transaction is done, then the system is going to allow the second one. It's going to be a situation where you cannot run 2 operations at the same time. So then you have the producer-consumer pattern. That you're going to see a lot of that as I cover web programming a little bit, and have all this other stuff. So let's see what else we have. So this is the part I really like. Let's see if I can shrink this down. Can't shrink that down. So we're looking at the different languages, and like I said earlier, C++ and C source code into its source code, and it's converted into machine code, and then that machine code runs directly on the operating system, and that runs on the hardware. So this is what's generated from that code, and you can see it's simple, but it's specific for that operating system. So each operating system is gonna have special functions in C++, so you could do what you have to do. So Java, on the other hand, it is interpreted. So you're gonna have your source code is gonna turn into bytecode at the compile level, and then that bytecode is gonna run on a machine-specific virtual machine. That's what they call it here. So the virtual machine will then talk to the operating system to generate the message, and once you're on this level, then you're running on then it's going through the CPU or the hardware level. And JavaScript, Ruby, and Python runs a little different than these two. The source code is gonna be ready to use, but it's gonna be running in a browser. The browser is gonna interpret everything, and then the browser is written in one of these other languages that's gonna then break it down to the hardware level. So that's not really as important as we work down. When you playing with on this level, you will not see a person in JavaScript saying that they are doing machine level programming. Like, you won't see somebody in JavaScript, probably even Python, trying to access memory directly, because that's not, JavaScript don't even have access to it, because you are writing for a web browser. Now, if I was creating a web browser, then it'll be a different story, because then I might have to interact with the hardware level, especially the way these browsers are now accessing our cameras, our phones, microphones, and all this other stuff. So writing a browser would be just like and most browsers are written in C++, C. Some of them written in Java and C#. I forgot all about C#. That's another interpreted language. That's for another day. So this is just some stuff on testing, and these are some great graphics too. So you can see that like unit testing, just showing, hey, all these tests are running good. Then this red, I don't know why this is turning red, but this is one thing I really liked about this REST API versus GraphQL. So when I get into web programming, I'm going to talk more about this, where when you're using the RESTful API, you actually going to send data out to the microservice, and then it's gonna go in, it's gonna come, it's gonna be a response telling you what we're looking for here, and then it's gonna give you the orders. So then you have to go back and get and look at another data structure within the microservice. So you got the user service. All right, we got orders, and then you got to go back and query the order, and then you're gonna get this information about the order. What I like about GraphQL is it looks a little more complicated, but it's a little easier. So right here is just like using SQL. You query the user, and then you tell it what you want: product, quantity, price, and then the response is going to be the user ID, product, quantity, and price, all coming back to you in the response. I like that. That's a lot better. So GraphQL, this looks like it's going to be the future. And JSON kind of work like that in a way, but this is a lot. Both of them has its places, so I can't really say one is better than the other one. But it's really good to see all this stuff here. So this was just a quick introduction to how web programming it interacts on levels beyond just playing with code. Like we said here, you might be working with situations where you have to play with other services, other servers, like the identity management system. You might have to go into a SIM for security. A lot of stuff going on. So I just wanted to talk to you quickly about this article. There was a lot that I covered, and a lot of stuff I left out because I do not want to. I do not want to make a video. This thing is to be a drawn out long video, because I didn't prepare to really go into deep details in this, because that's coming on my C++ in 31 days when I start course 2. So I just wanted to talk to y'all about that real quick, huh? Savage Scientist Ed. Meet you next video. Peace out.